All right, good morning, everyone. Today we're going to be talking about full stack deployment. Yesterday we talked about building our entire full stack application by connecting our Django API to our React front end. But today we're going to talk about what that looks like once we actually go and deploy it into the web or the internet. All right, so let's take a look at our project state as of right now. Currently, this is still the same project that we were working on yesterday. The difference is I am on a separate branch. If I run git branch, you'll see that I am on a branch called ready to deploy. If anybody's still attempting to follow along, all you have to do is run the get checkout command followed by the name of this branch, and you'll have the same exact code that I do. So here's our project. Currently, since I don't have a user, the only things I can do is log in or sign up. So if I go to login, I can see that I get logged in and now I have a different set of links. I could either go to list or I could log out. And in list, I can create things like deploy my full stack application. And there's a little bit of code there. It's asking me, hey, is this still pending? And we'll do this on AWS. All right, so there you go. So deploy my full stack application and we'll do it in AWS. We have a little bit of CRUD functionality, not the entire enchilada, but just a little so we could demonstrate it once we go into our actual deployed environment. And we can also log out of our application. So that's the current state of our app. Does anyone have any questions about the current state of our app? It looks a little different than where we finished off yesterday, but not to the point where it should throw us completely off. All right, doesn't seem like anybody has any questions. So let's talk about the difference between the two deployment environments, right? Or the two full stack environments. So here we have our environment that's running inside of our local machine whenever we're working within a full stack application. We have a Vite server that's serving up React. React has React pages and components being rendered by React Router. And some of those components or pages may be utilizing axios. On our Django server, we have our Django API, which is the project. We have a couple of Django apps to include Django cores and Django REST frameworks. And then we have API views, which work with object relational mapping queries, right? Which are the queries that we run into our database utilizing the Django's ORM system. And then we have serializers that we get from Django REST framework for model serializers. And then finally, we have our outlier here, which is PostgreSQL. Postgres doesn't exist within either one of these servers. It exists as a background service, completely separate from one another. But we do have the ability to connect to the database, right? And then we have a little bit of a workflow here as to how information happens. So local machine gets both servers running. Then we go to localhost 5173. At that point, the browser asks V, hey, I need something to render on the screen. V communicates with index.html, and it starts getting ready to render the app.jsx page, right? Or whatever it is that we told our router to get ready to render. From there, React pages and components may or may not communicate with our Django API views to try to get information to render on the screen, right? Our Django API views may or may not communicate with our database in order to formulate and return a response. But once that communication is over, our React pages get rendered and it gets returned back to the client. And that's our user interface, right? That's how it looks like when we're working within our local machine. That's where we stopped yesterday. Now, today, we're going to be going over the full stack deployment. All right, so in this case, we're going to have a couple of extra layers into our entire enchilada. You're going to notice that we no longer have a Vite server being rendered, right? So we have our local, we no longer have a local machine. Our local machine is going to be replaced by this EC2 instance. It's essentially like a virtual machine that's going to be bought on the web and running. All right, that's going to be our EC2 instance, which is going to be in charge of serving our entire application. Now, for this local machine, we need a way to handle requests. When you have requests working inside of your local server, or you're actually, working on your local development, well, we don't send that many requests in at once. When you have a application that's deployed, you can have a considerable amount of requests coming in at once, a considerable amount of responses going out, and you need a way to handle that. Well, nginx is a special type of server that can handle that much traffic. Right? Its entire purpose is to facilitate traffic and return effective responses. There, you could if you don't want to utilize nginx and you're a little bit more old school and you want to utilize Apache, definitely doable. We won't be teaching that here. We go over nginx instead. Now, our React application, we've talked about React and how essentially everything that gets rendered in React comes from one specific directory. It's called the dist directory, right? Inside of that dist directory, our entire React code gets compiled and churned into 3 files. All right, we still have index.html, which we had as normal, but then we have index.js, index.css, and I believe those are the 3 files that is stored within the dist directory. And that's our entire React application. Now, we don't have a Vite server to be hosting these static files. So instead, we're going to ask nginx to grab these files and host them for us. Now, when it comes to Django and our API, again, we don't have a Django server anymore. Now we have this thing called gunicorn. Well, we've never seen it before. And what is its purpose? Well, gunicorn, its entire purpose is to serve a bridge between nginx and our Python code. Right, so nginx receives HTTP requests in a different language, and it's trying to figure out how to communicate with our Python code. Python was never the language of the web. So we essentially need somebody to work as an interpreter to say, hey, this Python code means this to nginx, so that nginx can actually return a response, and vice versa. All right, gunicorn can grab the request from nginx, look at our Django API and say, hey, this code here means that we need to trigger this API view. And then Django can process that information. And then finally, we have PostgreSQL. In this image, we do have PostgreSQL nested within the Django API, but it works exactly the same as it does inside of our local machine. It's not going to be inside of any sort of framework. It's just that the Django API is the only one that connects to it. But PostgreSQL is still living as an independent child outside of nginx, gunicorn, or any of this, right? So nginx and PostgreSQL are essentially living side by side. And then finally, we have this Route 53. Well, what this Route 53 does, whenever you go to a web application, and I believe there's a command to be able to do this. Let me see. All right. So for example, if I come over to my terminal here and I do something like ns lookup and I put in google.com, well, Google itself is just an alias, right? It's just a naming convention that we're utilizing to paste on top of where this actually lives. But if you take a look here, it tells me, hey, google.com lives in multiple separate addresses, right? So we have 142.251, 116, and then after that, we have a couple of different microservices that are working off of that domain, right? Well, what does that mean? If we go over to TLDraw, the internet is actually, I always say this, everything is just boxes inside of boxes, right? It's essentially, think about it as in real estate. it's a ridiculous amount of lots living inside of one massive machine that is able to communicate with multiple machines around the world. And whenever you get a slot on the internet, well, that slot is purchased at a specific address, right? When I run it in my local host, I get 127.0. Whatever. But that's just my way to identify my local host. For example, google.com lives at this current address. Well, what does that mean? Why is that important? When I go into my into my machine and I go into Google Chrome and I type into the search bar, hey, I want you to go to google.com. Well, what happens is it essentially works like a phone book, right? The request goes out. The way the internet handles this is it looks for google.com and then it looks for its corresponding address. And once it finds the corresponding address to be 142, then essentially all that does is it redirects us to 142.1 and starts showing us what's inside of this virtual machine. All right. So what we're going to do today is we're going to buy our own slot. We don't know where exactly it's going to live yet because we're going to buy it on AWS and they're going to tell us which slot, which real estate it is that we're buying. And from there, we're going to start our virtual machine to host our own application. So that's the overview of what we'll be accomplishing today. Does anyone have any questions regarding what I've covered up to this point, kind of this overview? All right. If no one has any questions, let's go ahead and start working through this EC2 instance, right? Since this is the last thing we talked about, let's start working into buying our own slot and getting ready to deploy our application. So here on Amazon, I have this EC2 portal. I'm going to share this link here on Zoom. When you go to it, it's going to ask you, it's going to redirect you to the AWS console. From there, you can make your own developer account, and then you can travel back to this EC2. Once you're inside of EC2, currently you'll see that I have no instances running. You'll see something like this when you first initiate. It'll show you the dashboard. Here, it makes it very simple for you. You want to launch an instance, which is essentially, hey, I want to get a piece of real estate. All right, I want you to connect me to a piece of real estate. All right, so I'm gonna launch my instance. It's gonna ask me, hey, what is going to be the name? In this case, I'm just gonna name it X-ray. It's going to ask me what virtual machine it is that I want to utilize in there, or what environment it is that I want to have inside of my virtual machine. In this case, I'm going to utilize Ubuntu. It's going to push you to try to use Amazon Linux. You could choose any one of these if you are familiar or you feel better with any of these. The main reason why we choose Ubuntu here in the program, it's a huge community. Ubuntu has been around for quite a long time. And, you know, if you run into any unexpected issues, you can ask the community and somebody will be more than happy to help. It's more to have support than anything. Now, there's this Amazon machine image. We can see that I have it in free tier. I can choose different types, but I'm definitely going to stay within the free tier. All that we're changing here is the ability of its performance, all right? If I come down, we have the T2 micro, and this is just space, right? Performance and memory space. So we can see here that we have one CPU with 0.5 gigabytes. Here we have 1 gigabyte, and that gives me my free tier. And as you continue going down, you can see that it starts growing, right? Depending on the size of your application, how many users you have, you'll have to scale what kind of machine it is that you want to utilize. But for now, we'll stick with the free tier. All right, and then we have my key pair login. Well, how am I supposed to log in to this virtual machine, right? I don't necessarily have a way to communicate with it within my own local machine. I can't just bridge into it without some sort of doorway. Well, that's what this key pair login does. It's going to allow me to connect utilizing SSH. All right, so I'm going to name this my key pair. I'm going to create it. You can see that it gets put into my download folders, and we'll see how to handle that here shortly. All right, and then we go into my network settings, my security that I can create. So in this case, I want to allow for both HTTP and HTTPS traffic. And then you could say, where do you want SSH traffic coming from? Now, I just told everybody I'm going to utilize this PEM key to be able to access this EC2 instance through SSH. Well, the most secure thing that you can do is set it to your IP address, right? That way, even if somebody gets a hold of your PEM key in some sort of weird way, the only way they can enter this actual EC2 instance is if their machine shares the same IP address as yours. Now, just for simplicity's sake, I'm going to leave it as anywhere. But for security and for anybody else who is going to be deploying, try to utilize my IP or add custom. If you're trying to deploy as a team, you might want to add multiple IP addresses here so that multiple people have access to this deployed environment. All right, finally, we get into configurations. We don't want to change anything there. And then it gives me a summary of what it is that I'm trying to deploy. I'm going to deploy one instance with my security groups that I created, and it's going to be all in free tier. All right, so I could click launch instance. And very quickly, it's able to initiate my instance. So now if I go to EC2, I click on instances running. Looks like it's not running yet, but it will be running soon. While we wait for that to be completed and running, does anyone have any questions over the material that I've covered up to this point? Let's hear it, Tim. If you're speaking, you're muted.
There was two different ways to secure it. What was the other one? It was like ED something, ED1559, or what was the different encryption key and public key? And why would you use the other one?
Yes, I'm not exactly sure about the other way. The main way that I've utilized to be able to deploy has been PEM keys. I'll have to look into the other one. I wouldn't be able to answer that question. I apologize,
Don't
Tim.
worry about it. Don't worry about it.
Brandon?
You were talking about gunicorn for a little bit. Is that similar to Psycho PG, where it's like a communication medium?
I think its purpose is similar, yes.
Okay.
Is that like the most common one, the green unicorn, or is that like just the one we're using? Is it always different for like a communicator like that?
Yeah, it depends on the requirements of your application. So for example, the API that we have is a very static API, right? It's not handling any sort of asynchronous request. For example, let's say I made an application for a chat room, right? And this API had a living WebSocket that was speaking to that chat room and making live updates at the same time. Well, then in that case, I need an asynchronous server to be able to communicate, right? Because this operation is happening asynchronously. So rather than utilizing gunicorn, I would probably utilize something like hypercorn. right? So it just depends whether you want to deploy with WSGI or if you want to deploy with ASGI. That probably doesn't mean anything, so I'll share the documentation with everybody here shortly. That way everybody can take a look at that. Does that answer your question, Tim?
Yeah. Sorry to jump in front, Brandon. Just was curious.
All right, everybody. Well, now we have our EC2 instance running. We have officially bought a little slot inside of the internet. And if I click on this slot, it tells me, hey, your slot lives here. And this is where your slot currently lives. So now I can come here and say, hey, this is mine. All right, this is my slot inside of the internet. Currently, I don't have any address to type into it. So if I actually wanted to check it out, I would have to click on this open address tab. And it would tell me, hey, there's nothing here, right? Nothing shows up. This site can't be reached. It's non-responsive. This machine is not hosting anything. All right. Well, now I need to log into this machine and start hosting information. So let's move to that section now. So here in my deployment app, I'm actually going to utilize another terminal to manipulate files. So I'm going to, I need the X-ray depth. Let me make sure that that is inside of my downloads. Yep, X-ray depth, .pem. All right. So now I'm going to change directory back into my home. I'm going to run ls-a. Now you'll see that I don't have a directory named .ssh, and that's normal. Oh, actually I do have it, right? So in .ssh, it's going to be where you want to store most of these SSH PEM keys. So let me go ahead and change directory here into .ssh ls, and we'll see that I have a couple of other things to be able to enter old instances. So I have the CP portal PEM key. So now I can utilize my venv command to move from downloads. I want x-ray dep.pem, and I want to move it into this directory. So now if I run ls, you can see that I have my x-ray dep.pem, right? So now I have that PEM key. It's just a certificate. I wonder if I can still see it here. Oh, it won't let me see it anymore. All right. It's just a certificate. It doesn't look like it's anything fancy. Let me see if I can do code. Right. If I go into code xray.pem, it shows me this whole RSA encoded thing. Doesn't really mean anything to me. But what it does is it actually bridges me. It's telling me how to connect to my virtual machine that I just bought. So now let's go ahead and try to enter this virtual machine that we just bought. All right. Again, we're utilizing SSH to do this. And this is where things are going to get tricky because we're going to be utilizing a lot of Vim moving forward. Because we'll be working within this virtual machine. We no longer have VS Code available to us. So I'm going to type in SSH-I, the name of my PEM key. And I want to specify the machine that I'm utilizing. And then the IP address, right? So here's my IP address. I'm gonna copy it. So I'm saying, hey, I want to enter as my this X-ray dep key utilizing SSH. -I means I am the super user, right? I'm trying to enter as my super user. This is a machine running Ubuntu, and it is located at this address. Well, now when I run this, it's going to give me a prompt saying, hey, are you sure you want to utilize this? I'm going to say yes. And it gives me an error, right? Well, it's telling me, hey, this is a unprotected private key file. And this has to do with privileges. How do I know this has to do with privileges? Well, it tells me this key of X-ray dep has bad permissions, and it was denied. Well, that has to do with permissions. I'm not going to go too much into how we can determine permissions of each individual file. Let me see if I remember how to list these. So I think it's ls-r. Nope. I apologize. It's ls-l, of course. All right, so if I type in ls-l, it's going to show me all of my files along with the permissions that are corresponding to it. So here where you can see the 3 old PEM keys that I have, they all have read and write permissions for the super user, but everything else is taken away. And the way this breaks down, the first 3 dashes have to do with super user. The second 3 have to do with admin users. And then the last 3 have to do with just regular users, right? So that's how it breaks down. We're just specifying permissions in pairs of 3s. Well, currently super users are able to read and write, but my admin users are able to read and my user is able to read. So it's not being protected correctly. And that's what it's telling me. Hey, it's saying this is not protected the way it should be. So it has bad permissions and we're going to deny you access. So how do I protect this so that only super users have access to read and write? Well, we can look up codes. We know the code here in Code Platoon. The code here is 600. And this is actually interpreted in binary code. So 600 essentially turns into 110, 000, 000. And that's what all these are. They're just ones and zeros, right? And we want 110 and the remaining to be 0. So we're going to utilize the change mode command. We're going to change it to 600. And we're going to do this on the X-ray dep key. Well, now if I run ls-l, we'll see that the only people that have permissions to read and write now is the super user and the super user only. So now it's properly protected. So now that it's properly protected, I can run my command again. And that command to enter is ssh-i, I as the super user, want to enter utilizing this PEM key into a machine that's running Ubuntu at the following address from AWS. And now I get this. All right, it's telling me, hey, we're going into Ubuntu. If you need help, here's the documentation. Here's some management support, system information. It goes over a couple of different things, but we'll see that now I am within Ubuntu at IP 172.31.62. I am no longer, this terminal is no longer within my local machine. I am within my EC2 instance. All right. All right. Any questions over PEM keys or how to enter your EC2 instance utilizing PEM keys? And I apologize, Brandon. I just saw your question on the chat. I made an Ubuntu. Tim?
I noticed earlier when you changed the read-write capabilities that one of them didn't have an @ symbol on the end. If you would scroll up on the terminal.
Let me see.
Oh, I guess 2 of them now. What does that mean? The @ symbol at the end. Or
Yeah,
whatever that is.
I actually don't know what this decorator stands for. These two are definitely not PEM keys. These
Yeah,
two are something different that probably came with my machine. Whereas
okay,
the .pem are PEM keys that came from AWS. So maybe that's the symbol saying that, but I have to look into that. I'm not sure what that means.
okay. Cause yeah, the first time the known host was the only one that didn't have that decorator, and then known host old did. So I don't know. It was just weird. I just was wondering what it was.
Oh, that's true. Yeah, I'm not sure. Awesome. I'm gonna have to look into that. Thank you. All right. So now that we're within our SSH, how do I actually start seeing things inside of my little slot, right? My little address. Because right now, if I refresh it, nothing happens. Well, let's start by going from top to bottom. Right, if I go back to my drawing here, we can see that inside of my EC2 instance, the first thing that's supposed to live in there is nginx. Well, let's get nginx running then. And I apologize, everyone. I know we're a little bit, we're following a different flow than what we have here in the curriculum. I'm trying to demonstrate everybody the nesting of how this is all working. So let's go ahead and get nginx installed. And we'll do that. Remember, I am now no longer within my Mac OS. I am inside Ubuntu. So this is kind of where all the WSL users have an upper hand, right? Because you guys are all used to these commands. I'm going to run sudo apt install nginx -core. All right, it's going to ask me a couple of things here. I have nginx now running, or once it finishes installing. All right, so nginx is now installed. And now that nginx is installed, there's a little bit of configuration that I need to do to nginx. And actually, before I go into that, let me make sure this is okay. There's a little bit of configuration that I need to do to nginx. Now, nginx, again, it's a server, and it essentially works just like our Django server there. Our Django server did. It has directories and it has files in them that handle all of the configuration. But they're not found the same way. If I run ls-a here, you'll see that I don't really have much to go off of, right? I don't have my project. Nothing tells me, hey, nginx exists here. So how do I find nginx? Well, nginx is a background service, so it falls within a directory named etc. So I can change directory to etc, nginx, run ls there, and now I can see all of the configuration files regarding nginx. In this case, I want to vim into nginx conf. All right, and here we can see that we have the user as www-data. That's not what I want. I want the user to be Ubuntu because that's the machine that I'm utilizing. All right, so it looks like I made a mistake when going into Vim. I need to utilize sudo vim nginx so that it allows me to actually save my file changes. And now it saves them. All right, so I can go ahead and run head nginx conf, and we can see that the user is now Ubuntu. So now that the user is Ubuntu, I should be able to see the nginx directory or the static files being served by nginx. I just need to restart nginx. And I can do that by running, I'm going to go ahead and do cd tilde here. I'm gonna run nginx sudo service. I can expel nginx restart. All right, let's see if that did the trick here. It looks like it didn't. All right. Well, my intent was to show us the static files behind nginx first before we start going into everything else. But it looks like there may be something that I need to change here. Let me see here. Go for Brennan.
Did we verify that nginx is actually running?
Oh, let me see. Let's see if I run start. Yeah, so it's running. It's just not rendering the files. And I think I know why it's not rendering the files, but I don't necessarily want to take everybody down that rabbit hole.
I think running status would tell you if it's actually running or not. Maybe like you're calling start, but there's an issue. I don't know if it would respond saying, hey, something's wrong.
Yeah, so it's active and running. Let's see. I'm gonna check out what it is that nginx is actually rendering. All right, and sudo default. All right, so here in this default directory or this default file is what nginx is actually hosting for us already. So it looks like the only thing that's working right now is our index location. So let me make sure that it's linked correctly, and let's talk about what this means. So this
How
is
do you know that? Sorry, how did you know that was the only thing working?
that's what I'm about to cover right now. All right. So here we have our server. All right. This is the nginx server, and this is the configuration file as to how it's connecting. So it's telling, hey, I want you to listen in port 80. Port 80, for everyone's essay, is the default port of any machine. All right. So here I have localhost 5173. But if I were to go to port 80 at localhost, that is the equivalent of localhost itself, right? It's saying, hey, in the master port, the main port that we always render, I want you to connect to it. So it's connecting to the port of our virtual machine on AWS. And it's saying, hey, I want you to listen to this port. That's the only port we're going to be listening to. We don't have to worry about server name, but this works kind of like our URL paths, right? I'm telling, hey, the location @ I want you to try the files that exist within URI 404. So that's currently where that's being stored. Let me make sure that this is, I'm gonna give it one last attempt here. And if this doesn't work, then we'll move on into bringing our Django API, and we'll start from our backend. Yeah, so unfortunately that didn't work, but we'll see that here shortly once we start working with our Django API. So let's start talking about our own application, right? And how do we get our application inside our piece of real estate here? Well, in Django, there's a couple of things that we have to handle before we push this up to GitHub. So in Django, we currently have our base directory and we have all these other things, but there's things that we should be hiding, such as our secret key, right? That needs to be hidden. We have this debug equals true. Well, when we deploy, we don't want it to be true. And then we have allowed host, which also needs to change. All right, so let's start working through that. In our allowed host, we're actually going to allow for all for now. This specifically would be your IP address that you have. I'm gonna make a .env file here. And inside of this .env file, I'm gonna store my secret key. So there's my secret key inside of my .env file. Now in settings, well, I can say from .env, I want to import load.env. We call the load.env function here. Oh, I forgot to import OS, I apologize. So now, rather than calling my key directly, I can say os.environ.get Django secret key. So this load.env will find the .env file. It will load these environment variables into my current environment. From there, I'll utilize OS to enter my operating system's environment and get my Django secret key. All right. So now I have my Django secret key available. And finally, I can turn my debug to false. Good. This is all done. What else is missing from my backend directory? If I were to share this project with somebody else, how could they start running this project? There's something missing here. Let's hear it, Dan.
Is you have to do the pip install requirements.txt question mark?
Right, somebody would have to run pip install requirements.txt, but there isn't a requirements.txt, right? So we need to create one utilizing pip freeze. Oh, and I probably want to actually grab my virtual environment here. And now I can say pip freeze requirements.txt. And the requirements.txt file will be generated with all of the requirements to be able to run my application. All right, we're set. We're ready to go. With the exception of that .env, right? I actually don't want this to get pushed up to GitHub. So the final thing that I need is going to be a .get ignore. And inside of that .get ignore, I want to specify to not track the .env file. All right. And that is it. We are ready to deploy this application now. There's a couple of other things that you can do within settings.py to change it and make your application a little bit more dynamic and hidden. There are people who try to hide their database information, which is recommended. You can also, when we turn this into debug equals false, well, now we're not going to get errors. So if our application is failing in some sort of way, we need a way to be notified. You can add an email address to your settings.py so that anytime the application fails or it runs into an unexpected server error that's been unhandled, it will actually send you an email saying, hey, this is the error that we received. You might want to take a look at it. There's something going on here. All right. But we'll share the Django documentation with everybody. So in case you want to set that up, you can go ahead and do that. So now I'm going to back out, run git status, and here's my backend directory, right? .get ignore. Gonna run git log just so I remember where I'm at. So the last commit that I have is renaming front end directory. I'm going to git add, git commit. And the commit that I'm going to create here will be deployment ready. And then I can push this code into GitHub. All right, let's hear it, Arjun. If you're speaking, we can't hear you.
Can you hear me?
Now we can, yes.
Okay. So I have a question with the .env and like the git ignore. So like with the when we're pushing it to GitHub, so the .env will not be pushed. So what if someone is gonna be working on the same file and then gonna try to clone or pull the GitHub repo, and then the .env is not there? Will the secret key still gonna work once they push it back?
Yeah, that's a great question. So Django has a way of handling that. If we take a look here, oh, that's not it. I apologize. Weird screens. Let's see. Django secret key. So if you wanted to generate a secret key with Django, we can take a look at the Stack Overflow post. I'm pretty sure this is where I found it last time. Yeah, so there is a specific get random secret key function that you can utilize. And you can even run it from the terminal utilizing Python-C. Right, so if you utilize Python-C, you could bring in Django and print a new get random key. So then that way, whoever is cloning it can actually generate and paste a new .env file for a random secret key. Does that answer your question, Erojan?
So the secret key can just be generated when they can get like a different secret key when someone is gonna work on it, and it will still work, like the app will still work.
Yes.
Okay.
So the key is dynamic then, depending on who's working on it? Or is it not? It's kind of hard to tell. Because it says generate random secret key. Is that for each individual?
Yeah, so I think when it comes to Django, it is not that advanced to where the secret key is actually being checked against some sort of other database that's living out there. The secret key is definitely just a random string of characters and numbers. So essentially, you yourself can make your own secret key by just typing a ridiculous amount of characters in that string, and it would still function. Does that answer your question, Tim?
Yeah, and then when you said that it's highly recommended to hide your databases, what did you mean by that?
So what I mean by that, when you come down to the database configuration here, you typically for your database configuration, you also have something like host, and then the host would be the address. You may have something like port, and then, typically we see 5432, and then we have username, which in this case would be Francisco, and password.
I see, thank you.
Right, so all of this information here would essentially get placed inside of a .env file. All right. Okay. Any other questions? All right. Since there aren't, oh, go ahead, Mama.
Yeah, just my question about the database. If our application, our website start getting bigger and we have more data, how are we gonna save our database? How are we gonna save this data?
Yeah, so
Is that you using another server or?
that's a great question. So what we're doing here inside of Code Platoon, we're actually going to teach you to install PostgreSQL inside of this EC2 instance. If you want your website to be a little bit more dynamic and it's very data driven and you need it to handle data, I forgot what this one is called. There you go, RDS. You can tab. You can go to inside of AWS. There is something called RDS, which stands for Relational Database System. And here you can actually create a database, right? And it gives you PostgreSQL as an option. You can launch a PostgreSQL instance, just like we launched an EC2 instance. And then you would connect this PostgreSQL to EC2. Once you do that inside of AWS, it's going to give you an option to create something like an S3 bucket, or it's going to give you an option to create something called volumes, where essentially it's going to be generating backups of your data as they happen in real life time. So if at any point your server crashes or your EC2 instance gets terminated for, an unexpected reason, someone pushes something that they weren't supposed to push and you need a backup of your data, you could pull it straight from AWS and you don't have to worry about it getting manipulated inside of your EC2 instance. Does that answer your question, Momo?
Yes, sir. Thank you very much.
All right. So now that we have our information pushed, I'm going to go ahead and clone. So I'm going to run get remote -v to grab my remote branch here. And this is what I'm going to clone inside of my EC2 instance. So currently I run ls, there's nothing there. I'm gonna run git clone my deployment application. Now we can see it getting cloned. It's asking me for my username. Oh, that's not good. Oh, all right. It is trying to ask me to authenticate. Okay, and that's because it's a private organization. So let me see what I can do here as far as pushing it. All right. This is not part of the lesson, so if you want to ignore it, please do so. I'll make sure to leave a timestamp saying that this part is to be ignored. I could answer questions, but know that my mind is busy trying to get another repository running. Brandon, go ahead.
I'm pretty sure you could just create an SSH key to authenticate that way.
I could, yes, but that would be a juice not worth the squeeze. Um, all right. So now we should have it. There it is. We have main and ready to deploy. Good. Now I can copy, go into my SSH, and I should be able to clone it this time. There you go. Now it's cloned. Nice. All right. I'm gonna go into my project folder here. I do want to check which branch I'm currently on. So I'm in the correct branch. I'm on ready to deploy. That's great. So now I have my project. Well, now that I have my project, I need to also install everything to be able to run my project, right? I'm gonna need to have gunicorn now because I didn't have gunicorn before. I'm gonna need to install npm. This is essentially doing install fest from scratch all over again, all right? So let's start by doing sudo apt update. This is going to install kind of how we do pip -- upgrade pip. We're upgrading to the newest version of my installer. So now I can install Python 3. Let me actually move this up here. Might give us a little bit of a better visual and interaction. All right, so now I have Python and pip. Next, I can install Postgres. Okay, so now we have Postgres, and now I'm gonna try to create my user here in Postgres. So I'm trying to create I just created a super user in Postgres. So now I can type in PSQL Postgres and actually enter Postgres as normal. Great. And there's a couple of other installments that I need to do for PostgreSQL and PsychoPG to be able to speak correctly. So that one's called livepq-dev. All of this is inside of our curriculum. So I apologize that I'm rushing with the typing, but I want to make sure I get all of these installed before I break here. So now I can sudo apt install nginx -core, and I've already installed this by running it just in case. Let's see. I want to make sure I create my database. Oh man, what was my database? Let's see. To do DB. Okay, so create DB to do DB. All right, so that worked. We have our database. And then finally, I can start with migrating and making migrations. So let me ls change directory into my backend. If I run ls, I see that I have requirements txt there. So I'm going to run pip install -r requirements txt. I seem to have an issue there. Let's see. To install Python packages, excellent manage environment. If you wish to install a non-Debian package. Huh. Go ahead. Who is that? I'm not sure. Brandon?
Open your virtual environment in order to run that.
No, this doesn't require the virtual environment, but let me take a look here. Install non-Debian. That's a weird error that I'm getting. So I'm going to go ahead and install everything here. So I'm going to pip install Django, and it looks like Django seems to be the problem. All right. We're currently at 10 o'clock. I'm running into a little bit of issues. So let me try to debug this over our little break. And then when we come back, we'll continue on with our lecture. Currently it's 10. Let's come back at 10:10 to continue with the lecture. Thank you so much, everyone. Cool. All right, welcome back, everyone. So the option we ended up going with is going to be the option that Brandon recommended. We actually created a virtual environment called .venv. We then activated the said virtual environment, and after that, pip worked just fine. So we did pip install -r to install all of our requirements txt. All right, so thank you, Brandon, for that idea. All right, now the last thing that we're going to do now is we're going to go ahead and, oh, I'm in the wrong terminal. I apologize. If we can see, I can run ls, and if I run ls -a, I don't have a .env file. So currently right now, my secret key is gone. So let's go ahead and get that secret key going here. I'm gonna run Python, oh, excuse me. I'm gonna run sudo vim.env. And when I go into this .env file, I'm simply just going to copy the .env inside of my local machine. And I'm going to paste it inside of this .env inside of my EC2 instance. And now if I run ls-a, well, now I have my .env file with the correct secret key. Great. Well, the rest, we know how this works, right? We can run Python 3, manage py, migrate, because we want to apply all of our migrations into our database. There you go. So now we have all of our migrations applied into our database. Let's see, there you go. And now Django should be ready to go. Now let's start worrying about the front end. Gonna go ahead and sudo apt install npm. All right, that's gonna take a little longer than expected. npm is massive, so that makes sense.
You used a nano instance, right?
Not yet, but we are gonna be breaking into sudo unstable here shortly.
No, my apologies. When you created the EC2 bucket, did you use the nano, like the smallest processor they offer?
No, I think I used micro for free tier.
Okay.
Yeah, whichever one's free tier. I think nano cost and micro doesn't. I can't remember off the top of my head. Let me take a look here. Micro. All right. There we go. We have sudo npm. Now npm has been installed, but unfortunately, npm is not the most stable version when you install it at first. So now I need to install something that will regulate it, and that is n. All right, so I need to sudo npm install globally this n package, and finally this n package will stabilize npm. Good. So now I have the most recent version. I can change directory into my front end directory and run npm install. And this will install my entire front end package. All right. So there you go. npm has been installed. I have it running. If I run ls, we see I have these directories, which is what I expected. But now I need to get my this directory. And I'm going to do that running npm run build. Oh. Now if I run ls, we can see that I have a directory named dist. If I change directory into dist, we'll see that I have assets and index.html. And inside of assets, I have my some weird stuff that I was not planning to see there, but we can see that we have our JS file and our CSS file. So that's our entire React code gets compiled into one JavaScript file and one CSS file. All right. So now I have built out, we have everything to actually run our servers. If I wanted to, I could just run npm run dev and it would run normally, or I could run Python manage py run server, and that would also run normally. But that's not exactly what we want. Now that we have everything installed, we can go into the configurations for nginx. All right, so I'm going to go back into nginx here. I'm going to make sure that that config file is still up to date. Actually, I could just do that utilizing head. All right, so we see that our user is still Ubuntu. Now that I know our user is Ubuntu, well, I can go into our locations and change what it is that I want it to render. All right, so I'm gonna go ahead and change directory into sites enabled. Here we have defaults, and I can sudo vim default. All right. So now as far as default goes, I don't want to change any of this server listen because it's listening to port 80. That's where I want it to listen to. What I do want to change though is going to be this location portion here. So this location portion, I needed to know where to serve my HTML information. So I'm going to go ahead and run my insert mode here. I'm going to erase this line. I want it to go into my URI, go into index.html. Now, how is it going to find this? Well, I need to specify where the root file is located. I'm going to do so utilizing root inside of user, share, nginx, HTML, dist. Now, we haven't seen this yet, right? But this is just a path. I'm telling nginx inside of this path, you're going to find this index HTML. That's what I want you to render. All right. So let's stop there. You can go ahead and press escape, WQ to write and read. And now let's actually paste that our React code inside of that path. So I'm going to now change directory into user/share nginx HTML. And here we'll see that we have an index.html, right? Well, how do I tell my dist directory to be rendered in here? I'm going to run the cp command for copy. I am then going to go into tilde, X-ray deployment, front default, dist, and I want dist to go into this location. Cannot create directory.dist, permissions denied. Just gonna add that sudo command there. And there you go. Now we see that we have our dist directory. So now I have my dist directory inside of this user/share/HTML. Great. Let's go back into our configuration that we had for nginx. So etc nginx, sites enabled, and then sudo vim default. So here we can tell it, we're telling it to go into the dist directory and grab that index.html folder. Great. So everything's working well, or it looks like it's working well. Let's go ahead and make sure that our nginx is actually serving these files. I'm going to run sudo service nginx restart. All right, job for nginx failed because the control process exited with error code C system. All right, so I must have made an error somewhere. Let's go into sudo vim cd into etc nginx dash sites enabled. Usually when you see something like that, it has to do with a syntax error. So I must have made a syntax error somewhere up here. So I see there that I have an extra root, so that could also be a problem. Go ahead, Brandon.
Scroll down, please.
Of course.
Right there. Index.htm. Should that be index.html?
Index. Where?
Where it says add index PHP to the list if you're using PHP. I don't know if that you did anything
Talking
there,
about
but
this?
HTM. Yeah.
Yeah, so this line here is being handled by nginx. We don't touch this line.
Okay.
So we have our location, our root, which is user/share/nginx/html/dist. That looks right. URI. Here it is. There was my error. I forgot a semicolon. All right. So let's try to restart nginx. Let's run our status. All right, so nginx is running correctly. Well, let's go to our IP address and make sure it is running correctly then. All right, so at HTTP, because we're not in HTTPS, 54.176, et cetera, I now have my React application being able to render, right? So now I have my React application. You can see that it's a little different than what we usually see in our Vite server. Static files look considerably different once you render them on the internet than they do while they're in local server. In your local server, for whatever reason, they look nicer, and their CSS applies a little bit differently. Now, that causes quite a bit of an issue when it comes to development, because you would expect what you do in development to also reflect whenever you go to deploy it, and that's not necessarily the case 100% of the time. It'll look similar, but not exact. And that's going to be an issue that we fix with Docker here in the near future. All right. So now that I have my React application being rendered, let's actually get our Django API running. So now, in order to get our Django API, I'm going to change directory back into xray-dep, change directory into my backend. And here I'm going to pip install gunicorn. Now, gunicorn is going to be the service that hosts my project. And it's going to do that utilizing the WSGI file, which exists inside of the directory of to-do project. So I need to specify, hey, I want gunicorn. And, oh. I'm going to actually set up our server first to be able to run this. No, this will work. I apologize. So let's go ahead and run gunicorn, and I'm going to bind it to my project WSGI. So I'm just going to specify to do project.wsgi file. I want you to bind this file to this machine's port 8000. And I want you to do this in this mode. Well, look at that. We have a server running that looks almost like the Django server, but not exact. All right. Well, now I know that that's going to work. Since I know that's going to work, I'm going to move into etc nginx sites enabled. And I'm going to configure my nginx file of default. Now, currently we have a location at slash. But what if somebody's trying to communicate with our API? Well, remember we added a API convention or a naming convention for our API, where essentially we are telling the server to, hey, whenever you get a call that goes to slash API, well, I want you to conduct a proxy pass, because remember, if we look at our image here, oh, I just lost my image, didn't I? All right. We look at our image here, nginx, it's supposed to communicate with gunicorn, right? So we're not exactly telling nginx, hey, this is where Django is. I want nginx to know where gunicorn is located. And gunicorn will be located in http / 0.0.0.0 at port 8000. Finally, we close our proxy pass there. So now nginx knows how to find gunicorn. I need to restart nginx one more time. Did I spell that wrong? Let's see. Is it services? It is probably services. There you go. So now we restarted nginx. And now we can actually go back into our X-ray depth backend and run gunicorn to do project.wsgi -- find 0.0.0.0 at port 8000. All right, so there's our server running. Let's make sure we didn't break our front end application. All right, so I'm going to come back into our front end, then refresh it. All right, my front end is still being rendered. That's working correctly. Well, let's try to utilize Thunder Client now to communicate with our server. All right, so I'm going to run HTTP, and I need to copy that IP address because I forgot it. There you go. And I'm going to try to communicate to /API/test. And I believe this is a GET request. So let me go ahead and send said request. And now we get, hey, the test was successful. All right, this worked. I'm no longer communicating with my local machine. I'm actually communicating with my API while being deployed. Good. All right, my API can now run individually, and my front end can also run individually. But this is occupying my entire terminal. And actually, I pretty much took off. I apologize, everyone. I didn't pause for some questions. Let me go ahead and take the time now to press on the brakes a little bit, do a little bit of a review over what we've done, and answer any questions that anyone may have. So at this point, does anyone have any questions over what we covered? All right. If no one has any questions, I'm going to go ahead and push forward here. I don't want this server to occupy my terminal the entire time. So I'm actually going to put this server to work as a background service by adding the -- daemon flag. And by doing that, the server is running now in port 8000. It's just running as a background service. I can still send a request and it would still work. It's just not occupying my entire terminal anymore. All right. Now, my React application is not going to be able to talk to this server just yet. And the reason behind that, oh, I see a question from Brandon. Go ahead.
What does that mean? Like as a background service? Like,
Yeah.
yeah.
So background service, think about PostgreSQL, right? Like Postgres is running as a background service, it's not occupying an entire terminal. And even though you're not inside of pSQL, Postgres is still running, right? It's still holding on to data. It never stopped. All that data is still being saved and it's occupying a memory space and it's continuously running. Well, that's what we're doing with our gunicorn server now. I'm not in it. I'm not interacting within it directly, and it's not occupying a terminal, but it is running in the background, occupying space and memory. Does that
How
make
would you stop it if you needed to?
Yeah, if you needed to stop it, you could utilize the command pkill and then gunicorn. And that would kill the instance of gunicorn.
Awesome, thank you.
Of course. All right. So now our React application wouldn't be able to talk to our backend. And that is because we haven't changed the address from localhost to our actual address on the internet. So let's change that. I'm going to change directory back into my front end, go into source, and from there I'm going to vim into utilities.jsx. Now the good thing is that we isolated this code inside of this axios.create. So now I can easily just change one line. And by changing this one line, my entire React project will adapt this new way to interact with my API. So now I can escape, :WQ. Now it's reading and writing. Excuse me, that was writing and quitting. Now I can run npm run build. I had a brain fart there. To build my dist directory one more time. And now that my dist directory has been built, I can run sudo cp-r dist. And I want to place dist inside of user share nginx HTML. All right. So now I have placed this dist directory back into nginx. And now I just need to refresh nginx by running sudo service nginx restart. All right, let's make sure we didn't break anything. I refresh it. We can see nginx is still working. I should be able to sign up now. All right, so let's go ahead and sign up a new user. All right, a new user has now been signed up. If I go back here and I go into pSQL to do DB and I select all from users, it's going to show me the new user that I've created. All right, so my new user has now been created, and I did that utilizing my EC2 instance. I can create list. Hey, this list, let's go with coding is live. Confirm. All right, I can go back home, go back to list. Good. If I go into my application and I click here, I can see my token is being stored. So if I were to refresh it, everything would still work. It confirms my user. All right. I still have all my CRUDing application, and I can even log out. And you'll see that my token is now gone. I refresh it. I now have my full stack application completely deployed inside of my EC2 instance with my nginx hosting both my gunicorn and my React static files. I know it looks like a little bit of a black box because we've been in Vim and we haven't been interacting with actual files. But please remember that this is all just files and directories, right? Now, there's two more things that we need to cover, and we should be able to do them before the end of our lesson here. The first one is going to be our Route 53. So just like we have google.com, we need a domain naming system, right? So in my domain naming system, you can see that I have a couple of domains. If you wanted to have a domain, you can come to the dashboard, and here you could enter a domain name. So if I were to think about Pokédex proj, and I run it like that, I can click on check, and then it would tell me, hey, Pokédex proj, there is an exact match for it. It is .com, and they're selling it for $14. So you can buy your domain to be able to do this part. Now, in this case, I'm going to utilize this Tango dep. For this Tango dep, that's all my information. Nope, that's not it. I apologize. They seem to have changed the domain name system interaction portal, so it's taking me a bit, but I will figure it out. Just give me a second. Let's see here. There you go. I apologize, everyone. So it took me a while to get there. Let me go back in here. I click on Tango dep. From there, I click on view details. Then it brings me to this record folder here. So here you can see that I had a record where it was attached to this route. I'm going to change that A record. So I'm going to click on it. I'm going to say, hey, I want to edit the record. And this is going to be an alias. And instead of applying to this domain here, I wanted to apply to 54176. So I'm going to copy it, bring it back over to Route 53, and paste it. there you go. So there's my new domain name system. I can save it. Now I have tangodep.com. I can view its status. It looks like it's pending, so I need to give it a second here. Still pending, taking a while. Let's see. HTTP tango-dep.com. All right. So now we're at tangodep.com, and you can see that it's taking me to my site still. Everything still works. Right? I can still go to my site, and now it looks like I'm getting an error. So if I inspect and I go to my console, I get 4 errors. And I'm getting uncaught and promise errors for bad request. Well, now that I have a root 53 instance, I need to change my code again to communicate to this root 53 instance. So I'm going to change directory into my source. I'm going to vim into utilities, and I apologize, it's sudo vim into utilities JSX. And instead of interacting with 54176, this whole address here, I'm just simply going to put tango-dep.com. Going to escape, write and save. Again, run npm run build to build my static files all over again. Then I'm going to run sudo cp-r, my disk directory, and I want to do so into user share nginx HTML. All right. Finally, I can now say sudo service nginx restart. Gonna refresh my page here. Gonna try to log in. Now you can see that I was able to log in utilizing tangodep. I can still see all of my list. I can add another one just in case. Hello. And there you go. Now I have my EC2 instance, not only inside of my IP address, but working correctly within a root 53. I gave it an alias or an address named tangodep. Go ahead, Brandon.
Is this called a reverse proxy?
I'll have to look at the terminology. I'm not 100% sure. I apologize, Brandon. All right. So now we have our address there. We have google.com. In this case, now we have changed it to where instead of google.com, we have tango-dep. And tango-dep communicates to our address up there. All right. So now we're able to, we have our React application and our gunicorn running our API here on this address, but we can communicate to it or tell people to communicate to it utilizing tango-dep.com. And if I come here and I utilize the same tool of NS lookup, and I put tango-dep.com, you'll see that it ties to my EC2 instance, 54.176.131.97. All right. So everything's working great. I have my actual application, everything is deployed, but notice that currently I only have HTTP. It is not secure. Well, how do I update that? This is going to bring us into our final tool and our final step of deployment. We have all the guts in here filled out, but we currently don't have Certbot. I have a root 53 domain name system, but I haven't applied Certbot yet. Well, Certbot essentially gives us encryption mode that we can apply to our nginx. Right, so here I can say, hey, I deployed a site. It is an HTTP. It is running on nginx, and it is running in Ubuntu 20. Immediately after putting that in, this site gives me step-by-step on how to do this. All right, so it tells me, hey, you need to install snapd. So now I can go ahead and install this classic Certbot here. So I can copy and paste information. I have all the commands here on my right-hand side, so I'm not switching between screens. But I'm going to install classic Certbot. We can see that that's being installed. It doesn't matter where you install it. It's being installed to the system, to the machine itself, not into my front-end directory or anything like that. So now that I have Certbot, I can run sudo ln-s that's where Certbot is living. And it's going into user bin Certbot. All right. And I put /a instead of -s. All right, so that worked. And finally, I can say, hey, I want Certbot to interact with the nginx instance living in here. It's going to ask me to provide an email. It's definitely okay. All right, then it's going to ask me to provide, okay, I agree to the terms and conditions. Would you be willing? Sure. Please enter the domain name system you would like on your certification. So here I am going to just put the same domain name system of tangodep.com. All right, so now it's requesting a certificate for tango-dep.com. It's essentially ensuring that the EC2 instance matches the record for tangodep.com. We can see that the certificate was successful, and now I can reach my site at HTTPS. All right. Okay, great. Well, if I go to HTTPS, I'm going to cancel that. Gonna come to my V here. Now we can see that it is https://tango-dep.com. Well, let's try to sign up a new user. Okay, looks like we have FR there. We get a block. Well, my request, we can see here what the problem is, right? I'm inside of HTTPS, but I'm trying to send a request to HTTP. And it's saying, hey, you can't do that. You need to change this to HTTPS. So once again, I need to change directory into xray dep, front end source, sudo vim into utilities, and finally make the final change saying, hey, we're going to communicate over hypertext transfer protocol secure, meaning that all of my communication should be encrypted. I can write and quit. And then we go through the whole copy process all over again. So npm run build to build my application. All right, if you know all the steps, you probably could do all the setup and then run it once. We're doing it step by step so we can see the issue and the reason why we're doing things. But definitely you don't need to repeat this process as many times as I am. And then finally, we can run our little cp-r. I want to do my dist file, and I forgot to put sudo here. This is going to go into user, share, nginx, HTML. All right, and now we can say sudo service, nginx, restart. All right, I'm going to go ahead and refresh this site. Here we have fr.fr.com. Going to click on submit. I have a brand new user. I go to list, deploy application on HTTPS in AWS EC2 with a route 53 DNS. I can send that. Changes to being completed. My task has been done. And now I can log out. And that's it. That is our entire deployment site. All right. So what we did today is we purchased a piece of real estate on the internet utilizing EC2. We then went inside of this piece of real estate and we set up an AWS Ubuntu. We installed nginx and configured nginx to communicate with gunicorn. Gunicorn is binded to our Django API, which is speaking to PostgreSQL as our relational database management system. And then we grabbed our React application and stored all of our static files inside of nginx so that nginx can host them for this AWS EC2 instance. We then grabbed Route 53 as a domain name system to be able to reference our address in a more clean way rather than typing in numbers. I can just go to tango-dep.com. And then we utilize Certbot to ensure encryption and have an HTTPS of hypertext transfer protocol secure, making sure that all of our requests being sent over the internet are encrypted. And now we have our entire full stack application deployed on the web. So everybody here can go to HTTPS tango-dep and you'll see the same application being rendered. Does anyone have any questions regarding deployment or anything that we covered today? I know this is more of a try and then have questions, so definitely understand. Go ahead, Daniel.
So if we're making any updates to our full stack, do we have to go through the whole process again, go through venv or go through AWS and then redeploy our I guess our code?
Yeah, so if you added a new feature or anything like that, you wouldn't have to go through the entire process that we just did. You would just have to do a git pull, right? So you would have to pull from whatever origin it is that you're utilizing to make that new change. With that said, try to keep your code that is being deployed as clean as possible for deployment, right? So all of the changes that I made in Vim, such as, hey, this should be HTTPS, and then the domain name system, right? Instead of doing that inside of your EC2 instance in your deployed environment, do it in a separate branch inside of GitHub so that you don't have to go back and rebuild your disk file over and over again. Does that answer your question, Daniel?
Yeah, it does. So the process is first push our code to Git, and then you go through the EC2 process and just pull from there.
Right. Pull and then nginx service restart, and you should be good.
And then if we're making these like updates, we want to pull from a branch first to ensure that it's working correctly.
Right.
Thank you.
Of course. Orjan?
I don't know if I missed this part, but where did we, or when did we, what do you call this one, deploy the database? Or did we ever deploy the database, or it just came with the Django with the backend?
Yeah, that's a great question. No, we didn't actually deploy a database. We just inside of our EC2 instance, we ran sudo apt install Postgres, installed Postgres into this EC2 instance, and that's where it's living. So if I run psql to do db, it's inside of this EC2 instance. All right, we didn't make a RDS instance with AWS, if that's what you're asking. That's
Okay. Yeah, that answered it. Thank you.
Of course. Any other questions? Let's hear it, Daniel.
So one of the purposes of using the EC2 is to make direct changes without using the git pull, right?
So the EC2 is the place where you're going to be hosting your site Its purpose is not for changes, right? In an ideal world, if you have a continuous integration and continuous development deployment pipeline, you wouldn't log into your EC2 instance at all, if necessary, unless 100% necessary, right? All of this would be handled by either GitHub Actions or some sort of other CI/CD pipeline builder that would deploy all of your code into the EC2 instance. The purpose of the EC2 is to host your information and own a piece of real estate on the internet. Does that answer your question, Daniel?
Oh, okay. Yeah, it does. Thank you.
Rojan?
So is it a common practice for big companies to deploy a different database for their website during the AWS?
Yes, definitely it is. Most companies will have an RDS instance, or multiple RDS instance. You know, most companies will also have multiple servers. They don't necessarily only utilize one. If you are on the East Coast, your requests go to a different server than people who are on the West Coast, right? They share the same data because they're communicating to some sort of RDS system that's copying data from something outside of maybe like an S3 bucket that's sending data over and over again to these different relational database management systems, right? So it shares the data between them, but the servers and databases that you are speaking to, if you're on opposite sides of the coast, are different from one another. And that's just for efficiency. Does that answer your question, Roshan?
Yes. And EC2 is elastic, right?
Yes. Elastic Cloud, cloud-based instance, I think. I can't remember what it is right off the top of my head.
Okay, thank you.
All right. If there aren't any other questions, I'll be around. If anybody wants to deploy their site and they would like some help, please let me know. I'm more than happy to hop into a room and help out as well when it comes to deployment. But as of now, we're going to be kicking into our personal project time. Let me go ahead and stop the recording.